So today we're going to be dealing with inequalities. And these inequalities, we do them all the way up to grade 12, right? So this is your foundation, and we need to make sure that you fully understand everything related to this topic, okay? So for each of the following sketches, write down what type of function f and g are. I think we all can identify these: linear, parabola, hyperbola, and exponential. And then shade the section where f of x is greater than g of x, right? Now, if we look at this question in particular, right? Remember, f of x is a graph and it has an equation. What this is actually asking us is, where are the y values of f of x above the y values of g of x? Okay, so the idea is you're always going to look at the y values and see which values, or at which particular points, are the y values of f of x strictly above the y values of g of x. And the first reference point is the point of intersection. So this point here, looking at 1.1, these 2 points, we're going to use those in our answer, right? So what's f of x? F of x is a linear graph, okay? And g of x is a parabola. Now, we want to then shade the section where f of x is strictly above g of x. So what I'm going to do now, I'm going to use a highlighter and mark off the point or the interval with where f of x is strictly above g of x. So I've highlighted that point. Then part C, we need to write down all values where f of x is above g of x. Use your working from A above. Your answers will be an inequality, right? So like I said, the reference points we're going to use are the points of intersection. So I see that the point I've highlighted, or the points I've highlighted, are between what? They're between -4 and 4, okay? So what I always teach my students is, if your shading or your highlighting is unbroken, right? You see like the highlighting there, it's a straight line. If it's a straight line and it's unbroken, your inequality is also going to be unbroken. So it's basically going to be combined. So between which x values is the graph f of x strictly above g of x? It's between -4 and 4. Now look, you see here, there was no equal sign there. So our answer must also match, okay? So any questions relating to what I just explained? No?
No, ma'am.
Okay, awesome. So that's our first answer, okay, for 1.1. Now let's look at 1.2. F of x again, that's your linear. And then g of x is an exponential. Now, we want to then highlight where the blue graph is strictly above the red graph. So which parts am I going to highlight? Any volunteers? Okay, so I'm going to highlight it for you. That's the part where f of x is strictly above g of x. Okay, so I've highlighted the part that's strictly above g of x, right? And remember, we said we're going to use what? The intersection point. So for this graph, we only have one intersection point. Now, let's look where this point is. It's everything, which x values? All the x values going which way? That way on the number line. Can you see? It's going to be all the x values that are strictly less than 2. So it goes all the way up to -infinity. So now I want to express that as an inequality. So in doing this, since I've shown that it's everything on the number line going from 2, look at my arrowhead. It's 2, everything going which way? To the left, right? So that means I'm going to match look at your arrowhead here, and then you're going to say x is strictly less than 2. That's your answer for this one. Okay, so can you see that the arrowhead that you've marked off on the number line matches the inequality sign here? Okay. All right, now let's go to the next 1.3. Okay, so f of x and g of x, both of these are parabolas. Okay. Where is f of x, okay, which is the blue graph? Where is it above the red graph? Okay, so first things first, what are we going to do? We're going to highlight the portion of f of x, which is strictly above the red graph. Okay, so when I highlight it, it's going to be everything. Remember, we use our intersection points as the reference points. Okay, so I've highlighted the part where it is strictly greater than or strictly above the red graph. Okay, now that I've done that, okay, what do you guys think my inequality is going to look like? Any volunteers? So how is 1.3? Does it look like any of the ones we've done already? Or the highlighting portion? So it's kind of similar. Yes, someone's mic is on. Someone wants to say something? Yes.
Is it going to be 6 is less than x less than, or is it, I don't know. It's something 6x and then negative 6, something like that.
Oh, okay, so let's look at the intersection points, right? So the intersection point there, it goes to -3. Should I zoom in? Is it too small? Can you guys see clearly, or do you need me to zoom in? Okay, so
No, it looks fine. Ma'am.
okay, so the 2 points we're using is -3, okay, and 3, okay? So using those reference points, okay, if my shading is unbroken, as you can see here, it's between 2 points. So your answer for this one is going to be x is strictly between -3 and 3. Okay, and look at the direction of your arrows. Your arrows always have to look like that, okay, for these ones which are unbroken. So this would be your answer for this inequality here. Okay, so we don't look at when you're giving your answer in terms of x, right? You're not going to look at the y value here. You're going to look at the x values. Okay, all right. Now, 1.4, slightly more complicated, right? So we have a linear and we have a hyperbola. Right, where are the intersection points? Okay, that's one intersection point at -1, -1. Other intersection point, 1 and 1, okay? Right, so let's look and see where is the red graph going to be above the blue graph. So we have to look at the points where it's strictly above. Okay, so I'm going to highlight the first portion that's strictly above the blue graph. So red graph, that's the first point I'm highlighting. So it's that part there. Then, is there another portion where it's above? Yeah, there is. It's this point here. Okay. So remember with the hyperbola, you have an asymptote at, what's the equation of this asymptote of this hyperbola? Can anyone remember? What's the equation of this hyperbola? Asymptote, sorry. So you have 2 asymptotes for a hyperbola. One is x is equal to 0. The other one is y equals 0. Okay. So in your answer, you're going to have to include this one. So let us write the first portion of the highlighted part as an inequality. So from -1, okay, remember that's the point of intersection. Which part of the graph? It's everything going which way? That way. So like I said, we're going to use our arrowhead for this point, okay? So it's going to be x is less than -1. Can you see how your arrowhead matches your inequality sign? Okay, those two match. So x is less than -1. That's the first part. Now the second part of the graph, okay? The first inequality is x is less than -1. Then for the second one, the intersection point, we're going to use 1. Okay, how do you guys think I'm going to write this inequality for the second one? It's everything on the graph between -1 and 0. Why do we say 0? Because the graph or the hyperbola is never going to touch the asymptote at x is equal to 0. So when we give this portion or this answer, it's going to be everything between 0 and 1. Okay. Yeah, so this one, 1.4 was your more complicated type question, okay? Because you had two portions on the hyperbola that you had highlighted that were strictly above your blue graph, okay? So like I said, remember, if you have two portions or two parts of your graph, you're going to have two separate answers like we do here, okay? So that was 1.4. Let's look at 1.5. Now, 1.5 is also going to be slightly different. Why? Because if we go and look at where f of x, now f of x this time is your parabola. Okay, then g of x is your linear graph, right? So where is, or which portion is the parabola strictly above the red line? So we want it to be strictly above the red line, okay? So I'm going to highlight portions of the parabola which is strictly above the red line. So remember, we always said that we look at the intersection points. That's an intersection point there. That's an intersection point there. So those two intersection points must be in our answer, right? So first portion that is strictly above is that part there. The second portion of the parabola that's strictly above is this portion here, right? So which parts? It's everything on the graph from 4 going which way? That way, okay? So the first answer, x is greater than 4. Then it's everything going which way? From -4 that way, okay? So x is less than -4. So like I said, if you shade two different parts or two different portions, you're going to have two answers, and the arrowheads must match your inequality signs. Okay, so two answers because we've shaded two different portions of our graph. Okay, then let's look at 1.6. For 1.6 now, we also have two parabolas. Okay. So f of x, that's f of x, it's the red graph. Remember the question was, where is f of x strictly greater than g of x? So where is the red graph, okay, above the blue graph? Right. Let's see, where is the red graph above the blue graph? So let's go ahead and highlight. Okay. That portion there, that's where the red graph is above the blue graph, and this portion here. What did we say we're going to use? We're going to use the intersection points. Okay. If your highlighting is broken, that means your two answers, or you're going to have two separate inequalities. So it's from 3 going which way? That way on your number line. So x is greater than 3. That's one answer. Then the other one, it's everything going which way? That way. So second one, x is less than 3. -3, sorry. Okay. Any questions? Okay, I'm opening it up. Any questions regarding what we just did for questions 1.1 to 1.6? No questions? Okay. Now, so let's look at these ones now for 2.1 to 2.6. Okay, so we're not going to do all of them. Yeah, okay, someone's mic is on. Did someone want to ask something? Okay, so 2.1, f of x, okay, that's your parabola, and a linear graph. Okay, where is f of x greater than or equal to? So now look at what's changed, your inequality. Shade the sections where f of x is greater than or equal to. Solve the coordinates of the points of intersection between f and g. Read off the graph solutions to the inequality f of x is greater than or equal to g of x. Okay, so we've done part 2.1a. We've written down the types of functions f and g are. Then shade the section where f of x is strictly greater than or equal to g of x. So f of x is the blue graph. Where is the blue graph? Above the red graph. So it's going to be between there and there. Who can tell me, since I've shaded something and it's unbroken, what type of an inequality am I going to have? Lisa, what do you think?
I'm not sure, ma'am. I forgot what the thing's called now again.
Okay, so if your inequality is if your highlighting, like I've done here, is unbroken, right? That means your inequality must also be unbroken. Okay, so if I read off here, these are the 2 points, -3 and 3. These are the points of intersection for these graphs. So my inequality, or my answer for D, okay, x is between -3 and 3. But remember, there's an equal sign here. That means I must also include an equal sign here. Okay, so I've shaded the correct part. The points of intersection are there. If you work out these points of intersection, you're going to get the same answers, -3 and 3. Those are the points of intersection. Okay. All right. Now, 2.2, okay, because you have a straight line, okay, answering the part A. This is a linear and a hyperbola. Okay, so where is your linear graph? Because that's your f of x, right? Where's your linear graph? Strictly above, okay, your red graph. So it's going to be strictly above from there to there. There's also another point where it's strictly above there to there. Okay. Now, because you have a hyperbola, right? Remember, there is an asymptote at x is equal to 0. Okay. So this point of intersection here, okay, if you work it out, if you make the two graphs equal to each other and solve, you're going to see that this is -1 and this one is 1. Okay, so now, first portion. the highlighted part on the number line is everything going that way. So the answer for this portion of the highlighted part is x is less than or equal to -1. Okay. Now for this point here, this portion here, it's going to be between 0 and 1. Now, because you have an asymptote, what did we say about an asymptote? Your graph is never going to touch or equal 0. So that's why for this one, it's not going to have an equal sign because there's an asymptote there. But for -1, it's going to be equal to, because it actually goes through the point 1 and -1 there. Okay. Hopefully, I don't know if they'll put something this challenging in your test, but hopefully not. Okay, so this one was for your linear and hyperbola. Okay, let's see. Okay, let's look at the 2 parabolas. Right, now, this point here, this point here. So we have 2 parabolas, we've answered part A. Okay, then we want to highlight where is f of x. Now, f of x this time, that's the blue graph. Where is the blue graph greater than or equal to g of x? So the blue graph is greater than the red graphs at the points I've highlighted. Now your answer, okay? Look, it's going to be everything going which way? That way on the number line. So x is greater than 2. But remember, the inequality was like this. It had an equal sign, right? That means we must also put an equal sign here. Then for the other side, it's everything going which way? From -2 to -infinity. So x is strictly less than or equal to -2. Okay. There. Right. Okay. So average gradient now. Okay. Average gradient. Let's see. Sorry. Okay, so average gradient, right? If you have a parabola like this, 2x squared minus 2, what does this graph look like? It's like that. And this point here is -2. Okay, we don't know what these points are yet. Okay, you could work them out, but I'm just doing this sketch to illustrate what average gradient is. If I were to ask you to determine the average gradient between x is equal to 0 and x is equal to 2 for this graph here that I've just given you. Okay. So what they've done here, they've given you 2 points. So x is equal to 0 is going to be somewhere here, right? That's 0, -2. Then x is equal to 2, maybe it's going to be somewhere there. So what they're asking you to find is find the equation or the gradient of this line here. Okay, so I've joined the points 0, and we're assuming that that's 2. Remember, that's 0 and 2. So connecting those points just by looking at this line or this linear graph that I just drew, do you think it's going to have a positive gradient or a negative gradient just from the slope? Zazie, what do you think? Do you think it's going to have a positive gradient or a negative gradient?
I think it's going to be negative.
Okay.
Negative.
Okay, remember, if your graph, right, or if the line is upward sloping, that means it's a positive gradient. Okay, so if it's upward sloping, that's a positive gradient. If I were to draw a line going that way, this is downward sloping. So that means that your gradient would be negative. Can you see? All right. So since we've got the X values here, we need to find, so step one, find the corresponding Y values. How are we going to do that? By subbing X equals 0 and X equals 2 into your Y equals 2X squared minus 2. All right. So let's go ahead and do that. When X is equal to 0. So that's 2. That's 2. So Y equals negative 2. When X is equal to 2, let's sub it in 2 squared minus 2. So 4 times 2, that's 8 minus 2. Your answer, Y is equal to 6. All right, now you've got your points, right? The first point that we're working with, let's call that X1, Y1. When X was equal to 0, we got negative 2. So this one's going to be your X1, this one's going to be your Y1, right? Then your X2, Y2. When X is equal to 2, your corresponding Y2 value is 6. So all we have to do now is substitute it into our average grade or your gradient formula, which is Y2 minus Y1 divided by X2 minus X1. Let's go ahead and sub. What's our Y2 value? Our Y2 value is 6 minus your Y1 value, negative 2, then 2 minus 0. Simplify this. 6 plus 2, that's 8 divided by 2. So your gradient is 4. So that's your answer for average gradient. Okay, so what did we do when we wanted to find average gradient? We substituted in the X values to get the corresponding Y values. Okay, so again, let us determine the average gradient given Y equals 1 over X minus 3 between X is equal to 1 and X is equal to let's make it 4. Okay, between 1 and 4. Okay, so what's the first thing that I do, right? I said I'm going to sub the points X is equal to 1 and X is equal to 4 into the Y equals 1 over X minus 3. Okay, so what type of a graph is this? This is a hyperbola, right? So Y equals 1 over 1 minus 3. 1 minus 3, the Y value is negative 2. Then when X is equal to 4, Y equals a quarter minus 3. What's a quarter minus 3? It is negative 11 over 4, but if you leave it as a decimal, minus 2.75. All right. So what's your X1, Y1? And what's your X2, Y2? So X1, Y1, 1 and negative 2. And 4 and negative 2.75. We're now going to use our gradient formula. Y2 minus Y1 over X2 minus x1. Right. So first y2 value. Okay, some people also prefer it like this. And then this one's your x1, y1. It's up to you which one you prefer. You can just, adopt it as you like. Minus 2,75 minus 2. 4 minus 1. So the numerator simplifies to -3/4. Then 4 minus 1. This is 3 here. When you plug it out in your calculator, so your gradient is -1/4. So that's your average gradient. Okay, so that's how you do average gradient. Do you guys have any questions? We have 5 minutes left. Zazie, does the average gradient make sense?
Yes, ma'am.
Okay.